let's take a look at the Linux file system. And the first thing we're going to take a look at is a command pwd, shows current directory, current working directory. If I click on Applications, Accessories in Terminal, and I type pwd, it'll show you where you're at. /home/user. Now yours might be a little bit different depending upon who you're signed in as. This is a make directory command, and spring. And then I'm changing to that directory. Let me do a pwd there. You see it now says /home/user/spring. This is very similar to what you run across in Windows. If I bring this up in Windows and I go into C:temp and delme, I come up here and there's /temp/delme. The temp refers to a folder. The delme is a folder too. Same idea holds true here. These are folders. If I go to Places and go to, doesn't matter which one to start out with, I guess, home folder, I guess. Then this shows me I'm the user, and I can come here to FileSystem. I can go to min, so forth. These are folders. Let's see, user here. Let me go back one. And you see it's the same same files as you see there is what we see here. So this is the where you use commands to look at items instead of a GUI. Now absolute path names versus relative path names. You see this cd/home. Let's go do that. cd, get to take there, cd/home, and that'll change that directory. If I do a cd/bin, now I'm doing a space. Now this changes the directory to that, and if I do a pwd, it'll show you where you're at. Now if I did a cd space home without the slash, it comes back, tells me no such file or directory. Again, the that /home then refers to your root, and then off that is the home. Let me show you. If I go to cd space / and do an ls, you see the home directory right here. Let's do cd space home. See, I don't have the slash here now, do I? Then this will change to that. If I do an ls now, see I have different users. If I do a cd space user, now look where I'm at, /home/user. Well, first the thing I did was cd home, and then I did cd user. So that's based upon where I'm at, the relative. Now, if I go back here, this is the main root. If I do a cd space /home/user, that's an absolute. What makes it absolute versus relative is whether your beginning character is a slash or not. And that'll go to it directly. And then relative path names. Now the absolute is kind of nice because then it doesn't matter if you put this in a script. It doesn't matter where you're running the script at. It'll work because it's a absolute reference. But if I move a directory structure, if I move it to a different location, then while relative, if they're done correctly, relative paths will adjust themselves and work accordingly. Absolute pathing, if you do it in scripts, will oftentimes break. So if you have to be careful about it. If you're going to use absolute paths, then you need to make sure that what you're referring to will never change. And that's kind of a definite thing to say. It'll never change. Now there's some directories that you know never is going to move, like bin. The slash bin's been there for 20 years, probably more than that. Okay, now let's talk a little bit more about some of these utilities I've been doing. CD changes to another directory. So I've just been doing a change directory, and if I do an ls, then anything you see in that kind of bluish color is something I can change to. So I do CD space pictures, and now if I do a pwd, you see it's slash home slash user slash pictures. If I do an ls here, there's nothing there. If I do cd space ... that'll go back one directory. I was in home slash user slash pictures. I'm now in home slash user. If I do cd space ... again, I go back to just home. See right there. If I do cd space ... one more time, then I'm back in my root. Then cd space home, cd space user, and cd pictures. Oops, I don't want to go there yet. I want to go to pictures. So if I start typing PI and I press tab, it'll complete it for me, which is really nice. And I'm back to where I was. Sometimes you can just type the first couple characters into your tab, and then you're kind of set up. Now CD space and then this little tilde, drawing a blank, takes you home. What do I mean by home? Well, let me do a cd space / bin. This is absolute path. I'm going to the bin directory. Now if I do cd space and my tilde, let me do a pwd. See, I'm back to / home / user. This is the same location you'd get over here if I click home, or if I go to places, home folder. So this is your home. This is where all your files are. cd ... takes you back one directory. We've been seeing that over and over. Make directory creates a directory. So if I'm over here, okay, so I'm going to do a make directory fall 2014. I'm going to just keep files in there, for example. Now if I do an ls, you see the now I'm not sure if this coloring will be the same in every Linux system you'll run across. Could be some that's mainly black and white, but definitely with Ubuntu, it has some color coding here, which is nice. You can see what's what. I can see fall 2014 is in a bluish color and is a directory. So I can do a cd space fall 2014, and now I'm in / home / user / fall 2014. I can make directory Excel, do an ls, and see I have an Excel. So I can do a cd Excel. Okay, and let me make one more directory, F1. Oops. Make directory F1. Then change to it. Do a pwd, and you see that. Now if I want to go back to home user, here's my options. I can do a cd ... over and over. First one I'll go back to the Excel directory, next one I'll go back to fall 2014, the next one will go back to user. Which is kind of a pain. I can do absolute directory. So I can do a / home / user / fall 2000 or / user. That's where I want to go back there. And that's kind of a pain, because I have to type it all out. I have to remember what it looks like also. Well, now what I did there, I wanted to get back to this location. Or you can do a cd space tilde, and very quickly it takes you home. So again, very nice item to remember. If you're done a lot of CDs and you're kind of way out there, you don't want to remember the absolute path name, then you can do that. Now, if I do pwd, I'm at home / user. If I do cd space FA and I press my tab, see, it fills that in. Now if I do E, I probably just have to do an E and that's it. And tab fills it in. If I do F, tab fills it in. So again, you can very quickly fill that in with that. Let's see. Make directory, creates directory. Dot refers to the path name of the working directory. Dot dot refers to the parent directory. And you've been seeing me use the dot dot over and over. CD dot dot. If I do that, if I do CD space dot, see how it doesn't change? Because remember what the dot is. If I can get back there. Dot refers to the path name of the working directory. So, you know, if you're currently in that working directory, then doing a CD space dot doesn't do anything. Now remove directory. This deletes a directory. So if I got F1 here, if I do a remove directory, F1. Now if I do an ls, it's gone. Let me make it again, F1. And let me change to it, CD space F1. And I'm going to do pico letter.txt. Dear Sam, love this Unix. Wish you were here. Linux. Wish you were here. David. Okay, now I'm going to do a Control O to write it out. And then press Enter. And Control X to exit. Okay, so I got this here now. If I go back one, if I do a remove directory, F1, it'll tell me it failed to remove it. The directory is not empty. So Linux provides a safeguard to make sure you don't remove some files by accident. Now there is a way to override that. I couldn't tell you what that way is. If you read the man page on remove directory, you can do that. And if you look at the help, I think it's dash dash. Let me try that help. Verbose, for every directory, ignore, solely remove directory and ancestors. I thought there was a way to remove that. I'm not seeing an option there though. Man, remove directory. Remove directory and its ancestors. Maybe you have to actually do remove, get it completely cleaned out. Some of these I just had to play with to remember. My memory's poor. But again, you come here and you can just remove the file. If you want to remove the directory. Touch. Creates a file or changes a timestamp on it. Let me see. Touch. And I'll call it the file.txt. Oops. I want to do ls. There, dash L. It's been a few weeks. To do a long listing, I do the dash L. Assuming my date's off on this computer. Okay, January 4th, yeah. So that just created the file, and you can see it puts the current date in there. Notice the size of the file is 0. Well, you may be sitting there, it's like, well, why would you want to touch it and create it then? Well, to create an empty file, sometimes you do that to let something else know it's ran, like kind of a flag file. You don't want to actually do anything with it, but you want to create it to let somebody know that you've ran something. That's one technique. Another, if I touch letter.txt and see it was 1/4/2013, 1402. If I do ls-l, you notice that it now says 1405. It changes it to the current date and time. Used to be that have scripts set up that would go through and touch files in your Apache file system, And they would do that to make it look like you had updated them, because the search engines, the files that were changed the most recently were ones that they wanted to appear first. Well, the search engines now are smart enough to get around that, so they know not to just look for where you just touch something, but they actually look where something's changed. MVCP moves or copies files, works with directories also. MV moves a directory. So we come over here. This I always had to play with to get it right. I got this one here. Make directory F2, and let me move F1 to. I think let's try that. I might want to do a copy. Oh, there it is. Okay. Like I say, I sometimes have to play with it to get the syntax right, but that allows you to move a directory, a folder. You see my files are all there. If I do ls-l, even the time date and everything's the same. So move or copy. Not only moves, copies files, again works with directories. Now file permissions. ls-l displays permissions. What I've been doing over and over. I like ls-l. ls isn't bad itself, but let me go home. ls is shows you the colors. ls-l shows you colors, plus shows you permissions and so forth. Now this first character here indicates what kind of file you're dealing with. See the dashes here refer just to normal file. The D refers, and look at the blue. It's in blue, isn't it? So that refers to directory. The green one down here you see is a dash, which means it's a file. And we created this before, so that's just a file, nothing special about it. But it's an executable file, which I'm assuming what green indicates. Assuming these are red because of the type of file it is. We created those before, if you remember that. The next ones, these refer to your permissions, and we'll talk more about that. You see over here we got 3 different types. We've got all, group, and user. And to change a permission, you do a chmod, and then space, and then A, which would refer to everybody, plus RW. This adds read and write access to all. That's what the A is. And that's in terms of this test.txt. So let's come over here and touch the file.txt. Okay, ls-l. Okay, so we got that. Now do a change mod, and got to remember what was it? A plus RW. Okay. A plus RW, and the file.txt. Now if I do an ls-l, if I do my up arrow, there it is. You get that. You see everything has read write now. If I do an up arrow to go back to here, and the third one, I believe is X. Yeah, X for execute. So if I put an X here, and then press enter. Now if I do ls-l the file, you see all 3 of them has execute. So when you put the A on there, it will add it to all 3 locations. Now let's just change a user. So U is for user. And you can guess if the plus adds it, then what the minus does. So change mod, I have to actually spell it, user-rwx, the file.txt. ls-l, the file.txt. You notice the first three here are now dashes. The first three refers to our user. Takes away the access. Now, I'm probably signed in as administrator, so it'll probably still let me do something with it, but let's see. Pico the file.txt. It says new buffer. Assuming I typed it correctly, which sometimes is doubtful. No, I did type it correctly. It pretended like it was a new file. Well, let me do a change mod user plus r the file.txt, and now do pico the file.txt. I can see the contents again, can't I? So let me go ahead and write this out. So do a Control O, and I'll press Enter. Now see, it says error writing. The file.txt permission denied. If I do Control X to exit out, that's because if I looked at the file permissions on this file, for the user, all I got is read access. I don't got write access. So if I wanted to change it so I could write to it, I would do a change mod user plus write the file.txt. Now if I do an ls-l the file.txt, I'll see I have read and write. Okay, that's user. Let's take a look at group G. So we'll come back here. Now this is what our permissions are. Let's go and do a change mod. And what was it? G? No memory. Let me go look. G. And we'll do a minus rwx the file.txt. Now if I do an ls-l and the file.txt, you notice these are gone. So again, you can change the permissions. First one's user, next one's group, then the next one's all. You can change it by using this. R is read, W is write, and X is execute. X is for scripts. Like if you got a script you want to run. You can also use numbers, and there's a table in the book on that. I didn't really use this change mod that you see like you see here. Let me see. Pico test script 1.sh and make directory temp1. Control O, Control X. Change mod 755 test script 1.sh. Now I would do a ls-l on test script, and I did a tab to finish out the file name. Press enter on that. You notice the first one is read, write, execute, which is what I want. If I'm the user, I want to be able to read it, write it, and run it. But the world, if I had this like under my Apache folders, and it was a Perl program that I ran, for example, or wanted to run, for example, or some kind of CGI script I've written, I want them to be able to execute it, and that's what 755 refers to. I did that so much that it was easier for me to use the numbers and think of it that way than actually use the RWX and the A and so forth. Now I should be able to run that, I guess I should say. Let's see if I can do an sh test script 1.sh. I might have to do a dot. ls, what was it create? Temp something? Temp1. So I created a directory temp1. I thought maybe I got to do an asterisk. I'm remembering something wrong there. Unix temp. Oh, it's showing everything in that folder. Okay, I know what it's doing. Long weekend. And again, this is the example here. Change mod 755. Now you can also use access control list to handle what items can be accessed, and you can read that in the book. Hard links. Now let's take a look at this one right here. Do ln space files underscore a space file underscore b. Now if you change file b, then changes file a. I believe I got to create ln, or what in the world did I call it? File underscore a. Let's see, hello. And ln file underscore a file underscore b. And they're there. I was looking for them, I didn't see them. There's file a and file underscore b. I didn't use these very much, but you run across them every once in a while. And it says now if you change file B, then it changes file A. So let's try that. First, let's look at what's in file A. It's that. Okay, so pico file underscore B. Hello, David. Control O. Control X. Now cat file underscore A. You see it changed that file. To me, these were always kind of a pain to keep track of. So when you're working with this, this allows you to have a file here, such that it's kind of the working file that they will change. And then it automatically updates another file, and perhaps even a different location. Pretty much everything I did, if I wanted to change a file, I just changed it directly. I didn't use links like this. Now, if you do ls -i, that shows the inode number. If they are the same, they are linked. Okay, there it goes. If I can read correctly. So I'm going to come down here and do an ls -i. So if I look at file A and file B, you see how they both have the same number, so they're linked. Now symbolic links, they allow you, this is kind of a hard link. Let me go over here and remove file underscore B. And see, when I deleted it, it was actually a file. Let me read to you what the book says about that. That's the hard link. It talks about hard links are older, becoming outdated. See, a hard link to a file appears as another file. So that's what a hard link is. Now, a symbolic link, on the other hand, where a hard link is a pointer to a file, a symbolic link is an indirect pointer to the file. The directory entry contains the path name of the pointer to file. Now, let me see here. ln dash s. Hopefully I get the syntax correctly. ln dash s file underscore a file underscore b. If I do an ls. Now if I do an ls dash l, we don't have a we can think of it as not as like another file that we have there, but it's a symbolic pointer to this file. So when we work with this, then it'll modify this. Kind of works the same way, but you can see, I can easily see what it's tied to. See the file B, and then it's dash greater than file A. That, I mean, it was a lot easier for us to see than the hard link. So it allows easier use. You can spot them easier. You don't think of them as two separate files. Because if you didn't realize file A and file B were linked, you might change the one, and then indirectly it would change the other one. You didn't mean to. This way, it's hard to miss, because you can see the different colors and the L on the first character. Now, RM link, and then your link name removes the link. So now there's some other information in this. It's a good chapter. Well, all these chapters are good, but this one talks about different files, directories and files. Now the first one we'll take a look at, and this is on page 213, in case you want to follow along, is CD and then space and then a slash. This is the root. This is where all our main folders are. Now if I change to the bin directory holds the files needed to bring the system up and run it when it first comes up in recovery mode. If I do an ls, you see a lot of different names here. You see one says MV. Does that seem familiar? Move. SH. You saw me use that to run a script. Let me do an ls-l. Here's an ls, and you see that it has read, well, it has execute specifically, but it also has read across the board, because this is a file you can run. The ls shows your contents of your directory. So these are all your binaries, all your programs. So if you're wondering if there's some that you don't know what it does, you can come here and find out the name and go Google it and see what that does. You see some here are symbolic links, such that when I do the MT, then it's referring to this location. So I don't have to sit there and remember the location. That helps me to quickly get to it. So it's just not like tying one file to another file, because it doesn't make a whole lot of sense when you're thinking about in the same directory. It's just like, well, this doesn't seem to make any sense. Why would you want to do this? But you see, this allows us to very easily know where this, and I wish I could tell you what these mean. S-bin kill all 5, whatever kill all 5 refers to. SH down here refers to dash. We're going to hear more about those, but it's a shell. And you can set the symbolic link to point to different ones depending upon like the sign-in. Different people can have different shell scripts. Anyway, that's a bin directory. Now the boot directory, it says contains all the files needed to boot the system. I don't think I really go to boot very much. ls-l. You see the grub is a directory, and the rest are, looks like files. I have no clue what they are. More for somebody that is probably installs and does the networking side to understand this part. I did the programming side, so that's what I have exposure to. Let's go to dev. Contains all the files that represent peripheral devices. Now this is the part that seems real weird to me. If you come here, these refer to like monitors configuration, and it's kind of like ports. It's kind of like for hardware, they got files associated with them. And again, I never have done very much with these, but that's where they're located at. It says previously directory is filled with all possible devices. The udev utility provides a dynamic device directory that enables /dev to contain only devices that are present on the system.
A vast virus database has been updated.
There's Etsy. This is one I've had to use. I come here mainly to look for configuration files. Let's see, what does this say? Machine local system configuration files holds administrative, the configuration of other system files. One of the most important is the Etsy password, which contains a list of all users who have permission to the system. Etsy password. Now, let me take a look at it. Now, think what this is. Contains a list of all users who have permissions to use the system. When I bring it up in Pico, so you got root, daemon, bin. Let me do a down arrow. There, user, David, and David. Now you're not going to see the passwords actually out here. That kind of defeats the purpose of having a security, because they could hack in, get this file, and they'd have everything. But it does list all the different users. Now some of these are users used by the system for various purposes, so there won't necessarily be ones you could sign in as. Etsy opt configuration files for add-on software. Home, we've already talked about. Home directories are where all the users' files are. I got 3 users in my system. You probably have different ones on yours. I did a cd space /home for that. Shared libraries. I'm not sure if I've ever done it much with this. What's in here? I mean, it's obvious from what they say what they are, but I suppose if you're writing programs, you could use these. These are shared ones. It's probably system ones that perform certain functions. Library modules, mount, okay, that's not real exciting. Root, home directory for the root account. Permission denied. I thought I had obviously I'm not signed on where I can see that. Central system binaries, or an SBin. If you don't see what you're looking for in bin, look in SBin. That's other programs you can run. Now these aren't the basic ones that we saw before, like the LS and so forth, CD, MV, but shutdown, you can probably figure out what that does. Status. Now notice the blue color on it. Let's see, ls-l, more. That's weird, gets rid of the colors. ls-l. And probably went right by it. Oh, there's status. So niche CTL. So again, they're trying to make it a little bit more user-friendly. Missing job name. Okay. Obviously not what I thought it was. I thought it might give us status of the system if I left it blank, but obviously not. But again, more files you can run. Sys temporary files, user. I don't know if there's a user on here. Let's see. User? Yeah, I guess there is. Games. Solitaire. There you go. Games and educational programs. User include. These are looks like C files. Let me see what the book says. Header files included by C programs. If you're ever programmed in C, you know what a header file is. So that's what those are. Documentations under user share. And doc. Pretty slow. Ubuntu artwork. Whole bunch of information under here. var is variable data. /var. Crash. Nothing there. I suppose that's good. But this, what this says about it is the var directory is files with contents that vary as the system runs are kept in subdirectories under var. Most common examples are temporary files, system log files, spooled files, and user mailbox files. The assumption is, based upon the file name, is that crash, if your system crashes for some reason, it'll put log files out here where you can go and look at it, or some kind of files. I shouldn't say log files, because there is a place for log files. If I go to log, and we can see different items here. Pico boot.log, and this shows you everything loaded okay. That's kind of weird. Usually I'm expecting to see things not working fine, but what looked like when I booted everything up and it started all this, then see the OK message on that. Check forced. Okay, nothing too exciting there. What other log files are there? Mail.log. Nope, nothing there. Not surprising since I haven't been doing anything with mail. Kernel.log. Pico kern.log. And if you're a really technical person on Linux, you could read these and see exactly what in the world these mean, and they'd probably tell you something. Initializing. I'm assuming this was the last time the kernel was built, but I might have that wrong too. I'm not a real technical person on Linux. I'm more to the programming side of it. And that pretty well goes over the main folders. There's a lot of good information in the book. It goes in a lot more detail about symbolic links, and you can play with those and see. But this should get you started with it.